So we are going to talk a little more about comparing two methods. So we are going to new, and we are going to open a new data set. Um, we are going to open, and we go to this spreadsheet that is smartphones. In this spreadsheet, we have in the first column the number of the samples. We have 24 samples. We have tier samples, green tier, white tier, black tier, and these tier samples were analyzed. We determined the reducing capacity of each tier sample. It was done using the Follin-Cautel test, and the test was carried out using digital images acquired using a smartphone, and the absorbance measured with a spectrophotometer. So we have the proposed method and we have the reference method. You can see that the results for smartphone and for the spectrophotometer were in different columns, while these results were in different columns, because we have dependent variables. You can imagine that we have the first green tier sample, which was analyzed using a smartphone, and then it was analyzed using the spectrophotometer. So our data is paired. We can go to exploration. We go to descriptive statistics, and you are going to put the proposed method and the reference method. We here have the statistics. We can use the Shapiro-Wilk test to check data normality, and we can choose the interquartile range, the variance range, maximum, minimum value, number of observations, number of missing data, and we see that the proposed method and the reference method provided very close results. At this point, you can say, no, I am sure that both methods provide the same results, since the results are numerically close. There is some circumstance that both methods produce numerically close results, but the standard deviation is too small. And in these circumstances, we have two methods that provided close results, but they are not statistically equivalent due to very small standard deviations. This is not the case in here, but we can compare. We are going to compare the proposed with the reference method. We go to this push-up, and we go to paired sample t-test. We are going to select your proposed method and your reference method. We can check data normality here. We can see that once that the data was fused, we can consider that the data is normally distributed. For the Shapiro-Wilk test and the Anderson-Darling test, we can use the Kiki plot, and we can see that is some deviations for normality, but we can consider the data normal distribution. We can use the non-parametric tests and the parametric test. In this case, your data is normally distributed. We can use a parametric test. But the parametric test and the non-parametric test provided the same conclusion, that both methods were equivalent. Well, to the next video of our playlist comparing two or more than two methods, two or more than two dependent groups.